Dear students, today we will see one of the important algorithm which can be used in the and which will be used in the deadlock avoidance method, which is called as Banker's algorithm. Okay, I repeat, Banker's algorithm is used in deadlock avoidance method. So as we know that deadlock avoidance can be possible only when we know the number of resources available and number of processes available. Based on that, we can allocate resources to a process in such a way that there is no happening of the deadlock. So let us understand Banker's algorithm straight away with an example which will help us to understand it in a better way. Now the example says like this: by considering the following situation, calculate need matrix and safe state. Right now don't concentrate on this matrix which we have to calculate. I will tell you. Okay, by using this data we have to calculate the need matrix and the safe state for this particular situation. So here we have 5 processes which are called as process 0, P1, P2, P3, P4, and there is allocation table, then the max table, then available table. This, as I said, we have to calculate. I will let you know how to calculate. So each table has 3 resources. These resources are called as A, B and C. I repeat, these are the number of processes and these are the number of resources. So the need matrix has to be n by m. So n stands for number of processes and m stands for number of resources. I repeat, n stands for number of processes and m stands for number of resources. See here, we should know how to read first. Okay, so the process P0 requires 0 instance of resource A. Process P0 requires 1 instance of resource B, and process P0 requires 0 instance of resource C. Here you can see, so P1 requires 2 instances of resource A and 0 0 for the B and C. Now let us see what is this maximum. Maximum, again, as I said, ABC is nothing but what it is nothing but 3 resources. Okay, so 753, what indicates? That means A has maximum 7 instances. That means resource A can address at a time 7 processes. Okay, B has 5 instances of the resources. Okay, 3 instances of resources with the C, and available matrix says this is one dimensional. What it has presently, it is having 3 3 2. That means instance, that is 3 instances of resource A, 3 instances of resource B and 2 instances of resource C. I hope things are clear here. Allocation, max and available. Allocation means P0 has been allocated these many resources with respect to these are the instances. Okay, and maximum, that is available with the particular resource. I said okay. So in this case, what has happened? So P2 maximum, it is using 9 instances. It has 0 of B instances, B resource, and 2 of, it has maximum 2, uses maximum 2 of the resource C. I hope it is clear now. Okay, maximum means maximum utilization of particular processes of the resources or instances of the resources available at present what it is. Now firstly we will calculate the need matrix. Need matrix is calculated how? See, max minus allocation. Max is this, allocation is this. So we can see what we have to do. 7 minus 0, how much? 7. So here you can see need, we concentrate on this now, all of us. Let us see how need matrix is calculated. As I said, max minus allocation. So max data is 7 minus 0 is 7. 5 minus 1 is how much? 4. And 3 minus 0 is 3. So 7, 4, 3 with respect to P0. So what is next one? 3 minus 2 will be 1. 2 minus 0 will be 2. 2 minus 0 will be 2 again. So 9 minus 3 will be 6. 0 minus 0 is 0. 2 minus 2 is 0. And 2 minus 2 is 0. 2 minus 1 is 1. 2 minus 1 is 1. We're coming to last, that is process P4. 4 minus 0 is 4, 3 minus 0 is 3, and 3 minus 2 is 1. So this is our need matrix. That's what they have calculate the need matrix. So this is what we call it as need matrix. I hope you understood how to calculate the need matrix. Okay, so need matrix is max minus allocation. I think now you got it. 7 minus 0 is 7, 5 minus 1 is 4, 3 minus 0 is 2. Like that we calculate it. Once we calculate the need matrix, the next question is, what is the safe state for this particular system? Now we have to draw two matrices. One is work and finish. Okay, finish is what we are doing. Initially finish matrix will be having all pods, that is process 0, P1, P2, P3, P4, all processor pods. Okay, as and when they execute, we will make it as true. Okay, right now it is true. How we will make true, we will see it. Okay, now we have to use this need matrix to calculate which process has to be completed first and which one is next. See, initially we are taking this available. What is available? 3, 3, 2. So we have to check whether P0, how much instance of A, B, C are required? 7, 4 and 3. Now 3, 3, 2 is lesser than 7, 4 and 3, so it can't execute. So we leave it. Next, P1, can it be? So 1, 2, 2, yes. 1, 2, 2 is lesser than 3, 3, 2. So what we have done? We have executing first P1. Okay, I hope it is clear. P1 has been executed. So what we do is, once P1 is executed, this space becomes free, that is allocated space. So that space has been added to 332, that is 200 has been added. Now what has happened? 5, 3, 2. I hope it is clear. I'll repeat this point once again so that it is easy for us to understand other things. 7, 4, 3, can we execute? We can't, because the available thing is 3, 3, 2. Now what next? 1, 1, 2, yes, it can be. The reason is it will 1, 1, 2 is lesser than 3, 3, 2. So what I have done is, the P1's allocated resource will be freed now because it has been already executed here. So what has happened? We add both, that it becomes 5, 3, 2. So what I done was, false is converted into true now. Okay, P1 is completed. Similarly, next what has to be done? 5, 3, 2, 600, can it be? No, because 6 is bigger than that, it can't be. Then what is next? 0, 0, 0, 1, 1, yes, 0, 1, 1 is because 5, 3, 2. When we compare, 0, 1, 1 is lesser than 5, 3, 2, so it can be. So next process which is executed is P3. So P3 has been converted into false to true, and then this data will be added. This space will be freed and added to the what we call as 211. Okay, hope it is clear. Now when we add this freed P3 data, which is 211, it becomes 743. Now next one is what is that? 431. Can it be done? Yes, because 431 is lesser than 743. So P4, that is process 4, has 022, which space that space will be free. Now it is added to 002. So my next thing is P4 will be added. Then we add it, it becomes 745. Sorry. So when 743 is because P4 is which is lesser than that is 002 is lesser than 743. Sorry, not 003. That is 431 is lesser than 743, because we have to consider need matrix here. So the freed space of process 4, that is 002, is added here, which will become 745. Now next, which one has to be taken care? Now we have to come back. See, let us see whether P0 can be taken care. Yeah, 745 is what we have, and what need matrix is process 0 requires, that is process 0 requires 743, which is less than 745. So now process 0 will be taken care, will be given a chance. So the freed space, that is resource of P0, which is nothing but 010 is added here from the allocation table, which becomes 755. Okay, and at last remaining was, what was left? P2, which is 302. Sorry, P2 is how much? P2 is 600, that is 600 in need matrix. So when we say 755 is greater than 600, we can allocate it. So once that has been done, that is at last P2 will be done, P2 will be taken care, then the freed resources, that is of P2, which is 302, is added here, which will become 1057. So by doing this, I hope you followed the thing. So when we are doing this matrix, we should be careful that we are using need matrix for allocating or execution of the processes, and we are adding here the allocated data from the allocated matrix, which is from the different processes, that is to the resources. Okay, hope it is clear. Now safe space state will be P1, P3, P4, P0, P2. So I hope it is clear. Now we can cross verify also whether what we have calculated is right or wrong. So what we have got at the end, that work matrix, it is 1057. I repeat, 1057. You can cross verify. Now we have to check whether it is right or wrong. So here 3 plus 2 plus 5 2 is 5. Am I right? 3 plus 2 is 5, plus 2 is 7. 7 plus 3 is 10. What I got at the end, ABC 10. Okay, then it is correct. Now for resource B, it is 1 plus 1 is 2. 2 plus 3 is 5. I got 5. So, and last one is, what is that? With respect to resource C, 2 plus 2 plus 1 is 5. 5 plus 2 is 7. So by this way we can confirm that whatever we have calculated, the state is safer one, that is 1057. When we add these with this, we should get that answer, which is called as 1057. I hope it is clear. Thank you very much for watching.